Here we'll do an example of a quadratic inequality. Notice that this inequality has x's that are second power, therefore this will be a second power inequality. For second power inequalities, we will move all of the terms to the left side and get 0 on the right. This means that the 2x squared and negative 12 will both have to move. When you move the 2x squared, it will become negative 2x squared. When you move the negative 12, it will become positive 12. Then we combine any terms that we can. The 3x squared and negative 2x squared you may subtract, and 3 minus 2 makes 1, leaving us with just 1x squared. I'm not going to write the 1, we'll just say x squared here. The 8x and the 12 will not combine, and so we now have 8x plus 12 less than 0. Now we can try to factor that quadratic expression, 8x squared plus 8x plus 12. We're trying to get two numbers that multiply to 12 but add to 8. Let's think of numbers that could multiply to 12. We could have 12 and 1, we could have 2 and 6, or we could have 3 and 4. However, the one that adds up to make 8 would be the 2 plus 6. This means we'll break our expression into two parentheses and we'll have x plus 2 and x plus 6. And then we'll say this is less than 0. Now that we've factored the quadratic piece, let's solve both pieces of this inequality. We will say x plus 2 equals 0. If we move the 2 to the right, we would get x equals negative 2. And then if we take the x plus 6 and set it equal to 0, and move the 6 to the right, we will have x equals negative 6. Now we'll take this information to the next slide, and we'll try to draw a number line and figure out which parts of the number line will satisfy that inequality. We'll begin by drawing our number line and marking down negative 2 and negative 6 on the number line. We will also put the infinities on the left and right, with negative infinity on the left, positive infinity on the right. We know negative 6 should be further to the left than negative 2. Now have a look at the inequality. It says less than 0. This tells us two things. The first thing is that we have a strictly less than symbol, and so our negative 2 and negative 6 will be open circles, because if we have strictly less, those will always be open. We also know that we want our expression x plus 2 times x plus 6 to be less than 0 or negative. So I'll stop for a minute and make a note that our condition to satisfy the inequality is that our answer must be negative and the circles must be open. These open circles will split this number line into three regions, which I label A, B, and C. Region A is everything to the left of negative 6. Region B is everything between negative 6 and negative 2. Region C is everything to the right of negative 2. Now we're going to check a number from each region, A, B, and C, and see which regions satisfy our inequality. That is, which regions will make our expression negative. Let's begin with region A, and we'll pick a number that's to the left of negative 6, and we'll put negative 10. When we place negative 10 in for x, we will have negative 10 plus 2 for our first parentheses. We multiply that times negative 10 plus 6. Now, negative 10 plus 2 will give us negative 8, and negative 10 plus 6 will give us negative 4. Notice that we are multiplying two negatives together. Because we have a double negative, we can expect the answer to return positive. We actually don't really have to do the arithmetic, we just have to make sure that the signs are in order. However, the condition that we needed was negative, and region A returns a positive answer, and that is not a match. Therefore, region A will not be part of the answer, and we'll cross it out. We'll do the same thing for region B and pick an x that's in between -6 and -2. I will choose x equals -3. We will place -3 in for all of the x's. -3 plus 2 will give us -1. -3 plus 6 will give us +3. Therefore, we have a single negative times a positive, and a negative times a positive returns a negative. That does match the condition, though, because our condition was to be negative. This means region B is a match for the condition, and it will be part of the answer. We'll shade it green to show that. Now we check region C. We'll let x be something greater than -2. Usually 0 is a good choice because it's easy to do math with 0. If you let x equal 0, you'll have 0 plus 2 times 0 plus 6. This is just 2 times 6. We know that will be a positive number and that's not a match. This means region C is not part of the answer, and I'll cross it out. Therefore, according to our number line, there is only one part of the number line that fits the criteria, and that's region B, going from -6 to -2, so that's what we'll write for our interval notation. We'll note that the circles are open, and anytime you have an open circle, you will use parentheses around the interval notation for both -6 and -2 because they're both open. Therefore, our solution is -6 to -2. This is how we solve a quadratic inequality.